This paper made me realize that we are seriously underusing computational protein design because this is such a clever and brilliant idea. They basically built a system that lets cells record their own histories in a very visually satisfying way, and you can read it out later just by imaging. Here's how it works. They designed a pair of proteins that self-assemble into these particles that keep building cages around themselves. These two proteins are produced all the time, and the cage just keeps growing outward. Meanwhile, at time points of your choosing, you can transiently add in a label that makes a layer of the cage light up. These act as visual timestamps, so outer layers equals later time points. But the key is you can also encode fluorescently labeled versions of the proteins, which will only be produced when a particular trigger is present. Those form their own bright layer, which lets you determine the timing of the trigger event based on its relative position to the timestamp layers. They call the system Gemini, and it can resolve trigger events just 15 minutes apart, which is very, very good by molecular recorder standards. So they actually put the system into the mouse brain and show that Gemini can record a strong bout of neuronal activity between two timestamps. What they hint at is that you could, in theory, use this kind of system on a single cell level to record when individual neurons fired, and it would be so cool to be able to visually look at neuronal pathways and also see their activation histories, but this tech is brand new and it's not there yet. But I can imagine some lower-hanging fruit that would be equally interesting, so I'm excited to see how Gemini is applied in the near future, and also for the next gen of visual molecular recorders like this.